Okay, so thanks for doing this problem. And you nailed the mean because you found the midpoints, and those are great midpoints to use here. Let me get a point. Let me get a pointer going. So you found the midpoints, and you did that product. You found that product, and then you found the sum of those products and some of the frequencies and divide them, and that's your mean. And you're correct. The mode is the one with the highest frequency, which was the first class, which had that average of 43.5. And then you started to find the five number summary. Well, I mean, you took the percentile times how many items there were, and you found the index number. And this is where you kind of forgot where you were going with this. These are the actual index numbers. So we're looking for the 13th number, not we're not using 12.5. That's not the quartile, that's the index. And of course, with Dr. Stevens' rule of, I don't know, if you multiply the percentile times how many in your sample, um, that's the index number. And if that's not a whole number, you round up. So the 13th index number is what we're looking for. And since the first 25 numbers are in the first bin, that means the Q1 is going to be in that first bin, which is 43.5. Okay. And then um, for Q2, the median, we get the 25th number. So when that's a whole number, we have to average. So that's falling in between two numbers, right? And so we have to average those two numbers. And what I did here was we took the 25th number is the 43.5, right? And the 26th number is in the next bin. So I average those two numbers, and that's going to be the median Q2. Then for the Q3, we're back to not getting a whole number, so we round up the 38th number. And the 38th number will also be in bin 2 because we've got 39 numbers between the two of them, right? So that's the 47.5. And then, of course, to get the interquartile range, we subtract the quartiles, and it's 4. Okay, not we're dealing with the index numbers. Now, for the standard deviation, I know Dr. Stevens' quick method is you take the low, the high, and divide them by 2, add them and divide by 4, because there's 4 standard deviations there. 2. But this question really, because this is probably a skewed distribution, the best way to do that is to actually do the standard deviation calculation. You wait a minute here, and I'll get something set up for us, and we can look at that. Okay, so what I did here is I set it, put our numbers into the spreadsheet just so it's easier we don't have to calculate all those by hand. So here's the midpoints. And the way, of course, the standard deviation formula says take each value, subtract the mean from it. So I did that here. I just stopped writing down what I was doing here. So that's each of those numbers minus the 46.78. Then we're going to square each of those differences, and that's what that is. And then normally we just add up those square differences, but there are 25 numbers in that bin that have the same calculation here. And then there's 14 numbers, right? 14 numbers in the next bin that have that exact same calculation. So what I did is I took those square differences times the frequency and got these numbers. Now I'm going to add up all those square differences and all those frequencies. And then to get the standard deviation, we're going to take this number here and divide it, take that number and divide it by 49. So that'll be the variance, right? So here, let's have a good spell. Variance. So I'm going to click on that number, divide it, that number divided by 49, because it's 1 less than the 50, right? Now to get the standard deviation, we have to take the square root. Standard deviation. Standard deviation is we'll do the square root of that variance number. That's the standard deviation for all those numbers. Okay, so other than that, and so we see, maybe just get you ready for the quiz, we do see a right through distribution. I cut out your your histogram. It's right skewed. The mean is greater than the median, right? So that supports, see, there's the mean and there's the median. So on a right skewed distribution, we would expect to see the mean bigger than the median. So that's right. And so if we were to talk about outliers, we would want to use the median and we would want to use the 1.5 IQR test, right? So we take the IQR, multiply by 1.5, subtract it. But it doesn't really make much sense when we're dealing with these group distributions where we don't know the actual numbers. But it is certainly right skewed. Okay, so hopefully that helps. On the exam, I'm not going to ask you to work aside from finding the mean of like this. I'm not going to ask you any of these other calculations. I just wanted to help you see if people could do it and get that help. Okay, let me know if you need anything, have any questions about this.